What's up, guys? So today we're going to be making a giant knife using nothing but two major power tools, an angle grinder and a drill. We're also going to be doing our heat treating inside of our home kitchen oven, as well as just a regular old wood fire campfire. This is a project that just about anybody who can run an angle grinder can do. So with that being said, let's get started. All right, so real quick, let's talk about steel. One of these things right here is not like the other. And the reason for that is because of the carbon content. This piece right here in particular, this is a piece of 1084 high carbon steel. 1080 or 1084 are going to be the two steels that I would recommend the most for absolute beginner knife making. They are the easiest to heat treat. Basically, all we need to do with 1080 or 1084 is to get this up to around 1475 degrees Fahrenheit and then quench it in canola oil. That's all we have to do to get this steel to harden. Both of these two pieces of steel right here are from a local hardware store, or Lowe's or Home Depot, and they will not work for knife making. They simply lack the carbon content in order to harden. Now, as far as the best place to buy 1080 or 1084, the best thing I can tell you to do is to do a Google search and search in 1080, 1084, and find a place that will ship it to you the absolute cheapest, because the steel itself is not that expensive, maybe 10 or 15 bucks for a piece big enough to do what we're going to do today, but the shipping price is going to be what gets you. Now, the steel that I'm going to be using is a piece of 1/8 inch by 3 inch. This came 48 inches long, but some places will sell this in shorter lengths, 18 inches or 24 inches. The place that I bought this only sells it in 48 inch lengths, and even this big 48 inch piece was not that expensive, maybe 25 bucks for this giant piece. Now, the shipping on top of that was a little bit more, but you can make a bunch of knives out of this single piece. If you have any other questions on the particular steel to use, don't hesitate to ask in the comments and I will try and get back to you. All right, so there's a rough design drawn out on a piece of steel. Biggest thing that you don't want to do is make your handle too skinny. It's best to draw out your handle a lot thicker, a lot wider than you think it needs to be, because you can always go back later and take some more of this off. You can never put it back on. So the disc I'm going to start out with is basically just a 1/16 inch cutoff disc, and you can see how thin that is. That's so that we can cut out the profile of our knife and have nice thin grind lines. All right, guys, so because I can't talk and grind at the same time because I'm wearing a respirator and safety glasses and all kinds of other stuff, it's voiceover from here on out, or at least until we get to the parts where I'm not using the angle grinder. But essentially what we're doing here is we are cutting out our basic knife design. This is called profiling in the knife making world, and we're just, again, using our grinder with our 16th inch cutoff disc and cutting out the knife shape. So once we have a rough knife profile cut out of the piece of steel, we're going to switch over to a 1/4 inch thick grinding disc. They actually sell these slightly thicker than a 1/4 inch, I believe. It doesn't matter. You just want to switch over to a thicker grinding disc. It's going to be much more efficient at removing the rest of this material. So we have our general blade profile roughed out here. What we're going to do now is we are just going to clean up all of these jagged edges with a hand file. So I don't know if you can see all of these dips and waves in here. We're just trying to file all those down so we have a nice smooth kind of contour along the back here. If you want to leave this straight across, you certainly can. So making a knife with an angle grinder is great, but one of the big problems that you're going to run into is kind of having jagged edges on everything, and files are a great way to help smooth that out. All right, so what I'm going to do now is go ahead and switch over to something called a flap disc, and it looks like this. This is a 40 grit, but they're basically just a bunch of little pieces of kind of like sandpaper epoxied together and a grinder disc. And here I'm just using the flap disc to kind of smooth everything out along the spine of the knife, as well as the cutting edge where we're going to be putting our bevels, just removing any burrs or anything like that. We're also going to be using this disc to help cut in our bevels. This disc removes material a lot faster than you think it would, and they actually last quite a long time. I'm kind of surprised by them. So as I was kind of grinding here, I decided that the knife would be even more awesome if I put a slight recurve in the middle of the blade, and that's exactly what I did. So I ended up switching back to the 1/4-inch grinding disc and ground that recurve in, and then went back to the flap disc to clean everything up. Alright, so now that we have everything kind of smoothed over and rounded off and all that other good stuff with the flap disc, we're going to switch back over to the 1/4-inch grinding disc, and we're going to start grinding in the bevels. Alright guys, so basically what we've done is we started to grind our bevels, and we've ground off a little bit on each side, and we've brought this to about a dime's thickness right in the center. That might not be quite a dime's thickness, but it's close, and it's about even all the way down the entire bevel. Now the reason that we do this first is we grind both sides to the center point first is so that now what we can do is we can go back and feather this bevel all the way out, and we don't have to mess with the center line of the knife, and that helps us keep the bevel right in line all the way down, all the way to the very point. So what I'm going to do now is I'm going to go back and I'm going to do the same thing to this portion of the blade, and then our bevels will be centered all the way down the entire length of the knife. So it's important to note here that you do not want to grind too thin before heat treatment. If you grind your edge too thin, what will happen is that you'll greatly increase your chance of cracking during heat treatment. You want to leave about a dime's thickness there on the edge of the bevel. Now, if you do find that you have ground your bevel a little bit too thin, by the time you're done, it's not a big deal to go back and take a file and just thicken that edge back up a little bit. So here we've just switched back over to the 40 grit flap disc, and we are putting a convex edge on this entire blade. And essentially what we're doing is we're just working that bevel all the way up towards the spine of the knife. Now one thing that you also want to try and do is try to remove material off of both sides of the knife as equally as possible. The reason that you want to try and do this is because during heat treatment, thicker parts of the steel or thicker sections of the knife will actually cool down slower than thinner sections. And if you have a bunch of thin and thicker sections kind of unequally distributed along the entire length of the blade, you'll have unequal cooling and thus creating a warp. Now we're using an angle grinder here. We're not using super precise pieces of equipment. So, you know, just do the best that you possibly can with it, and it should be okay. Now we'll just go ahead and drill a couple holes in the handle. This handle is going to be paracord wrapped. So we're going to drill one hole towards the front of the blade where we want the end of our paracord handle to stop. And then we'll drill 2 holes in the back of the blade so that we can tie off our paracord. And then I'm just enlarging the holes here with a 1/4-inch drill bit. Now, if you do not have a drill, this step could be skipped. You can still paracord wrap a handle without the holes drilled in the knife, and it'll be just as good as a knife handle with the holes. It just makes the paracord wrapping a little bit easier, especially easier to get started and to finish up. And another thing to mention real quick here is if you're going to drill holes, now's the time to do it. You cannot drill your holes after heat treatment without spending a ton of money on drill bits. So what I've done is I just switched out to an 80 grit flap disc, and we'll just go ahead and smooth out a lot of these deep scratches, and we'll get it as smooth as possible with what we have. So we pretty much have this ready for heat treatment. All right guys, so yeah, we're out here gonna do the heat treating in literally just a fire. The one thing that you're gonna need is something to force air into the fire. I'm actually using a heat gun. You don't need to use a heat gun. A hair dryer actually works better, but I don't have a hair dryer because I don't really have that much hair. I'm gonna use this to get the fire going and to get the fire super hot. You're probably not gonna be able to do this without some way to force air into the fire. So while the fire's heating up, we'll go ahead and get our oil ready. I am using kind of a deep fryer, turkey fryer pot. Basically, you just need something that's going to be the length of the cutting edge. Now, the canola oil that I'm using is also the cheapest stuff that you can buy. I think I bought this at Walmart. It costs $2.99 a gallon. So what is that? 15 bucks for 4 gallons. So it's fairly cheap to get this going. You can use water if you absolutely must. I would not use cold water. I would use water heated to around 150 degrees. This oil will also be heated to around 120 degrees, 150 degrees. But if you do use water, know that you are greatly increasing the chances of cracking when you go to quench this. So The best way that you can actually preheat your oil is to take a piece of scrap steel. I'm just gonna use this old saw blade. I want to just put that on the fire, let it heat up, and then we'll cool it off in the oil. So this is about what you want here. You want this nice bed of coals, at least as long as the entire blade. We're also gonna try and put this like this, because if we lay it on its side, it has a chance of warping. All right, so we got our knife in the coals. Essentially what we've done here is we've taken the knife and just buried it up into the coals. We're putting the cutting edge down. That way the cutting edge stays in the coals and ends up getting hotter. So now I know you're asking, how do you know when you're ready to quench? How do you know that you have the blade hot enough? Well, essentially what you need is you need a magnet on along a stick or one of those little things that extends like I have. You can pick them up for like $1 or something, again at the dollar store. They work really well. And what you want to do is you want to heat this blade up until the entire cutting edge becomes non-magnetic. So the best thing to do is to heat the entire cutting edge up to non-magnetic, then put it back on the heat for a minute or so to get a little bit of extra heat into the steel, and then do your quench. So when you go ahead and do the quench, it's best to quench straight down as quickly as possible. Try not to hit the bottom of the oil pan like I did here, but quench as quickly as possible, and also agitate the blade in the oil. Don't use a swirling or stirring motion. You want to kind of rock the blade back and forth, kind of slicing into the oil, and that will help cool the steel as quickly as possible. Once a knife stops smoking, when you pull it out of the oil, you can simply take it out and let it cool to around 125 degrees or so. Then we want to get this into the tempering oven as quickly as possible. We're going to be using our home kitchen oven, and we're going to be doing 2 1-hour cycles at 400 degrees. So what that means is we'll leave the knife in the oven for 1 hour at 400 degrees, then we'll take it out, let it cool to room temperature, and then put it back in the oven for 1 hour at 400 degrees. I'm not super sure what surface finish we're gonna do here, but I've got a couple of little things I might try. This is just a wire wheel. This shouldn't scratch the surface because these wires are gonna be softer than the blade itself. So we'll try and just take some of the edge here because I kind of like this heat treat finish we got. But I think that eventually this is gonna kind of come off a little bit. So I guess we'll just try this first and go from there. I should mention here real quick that you want to take super extra careful precautions about not overheating this blade. You do not want to get it over 400 degrees. Now the super thin edge here, this can overheat in seconds with an angle grinder. So dip it in water often. You can keep a spray bottle full of water next to you and just kind of spray it off. Whatever you have to do, go out of your way 100 times over to keep this blade cool, because if you overheat it, you basically ruined it and you got to start over. So I just did a wire wheel finish on this blade, and I think it turned out okay. For a knife that's made inside of a day, it works just fine. If you want to take the finish further with sandpaper and do a bunch of hand sanding, that's perfectly fine. The choice is up to you. All right, so I'm going to go ahead and switch back over to a thin disc here, and I'm just going to use this to put the secondary bevel on the knife. And basically what we're going to do is we're just going to very gently put in this secondary bevel, or the actual sharpened portion, and then we'll take it to a cheap stone and we'll sharpen it. Using the 16th inch cutoff disc is a quick and dirty way to put a secondary bevel on a knife. It's really not something that I would necessarily recommend because you could screw up the bevel relatively quickly. If you want a much more precise control way to do it, use a stone or sandpaper and just put it in the traditional way. But the whole point behind this particular knife is something that you can make in a day with relatively little effort and relatively little handwork. So you can definitely use an angle grinder like this to put in a secondary bevel. You can raise a nice burr and you can get the thing kind of crazy sharp with just an angle grinder, surprisingly. And now we have a nice solid burr all the way down the entire length of the blade. So if I run my finger up the opposite side, I can feel almost that it catches. It'll actually scratch your fingernail. And that means that you have apexed all the way down the entire length. Apex basically means when you come to an exact point right in the middle. What will happen is the metal will start to curl over itself when that happens. And that's what you're feeling. All right, so because this is a recurve, what I'm going to do is take a hammer handle that's kind of semi-round. A nice round dowel would work better, but I don't have one. I'll take some 320 grit sandpaper. All right, so let's see if we can see this here. It's gonna be really hard to see, but we've got a little burr there that's gonna be working its way back and forth, and our goal here is to try and break that off. That right there's part of the burr that's beginning to come off. That's why a lot of times you'll hear me refer to it as a wire. That's because that's exactly what it looks like. So let's see if we can just kind of work this off on the strop. That's way sharper than it should be. I just got done stropping it for now. It is, it's pretty daggone sharp now. We could get it a little bit better, but this will cut paper no problem. I'll show you later. So now it's time for the handle. I'm just doing a simple paracord wrap on this. The first strand that I wrap around here is just the outer strand of the cord with the inners removed, and we'll just tie that off. And then the outer layer is the full paracord with the inner. And that makes a, well, it doesn't make a great handle, but it makes a workable handle. It's much better than not having a handle at all. You could definitely wrap another layer around this to make it even more comfortable, or you could go a different route and just put regular old scales on here and shape them with an angle grinder. Maybe that's something we'll do in an upcoming video. But for now, this paracord handle does the job. Again, the whole point of this knife is to just have something that you can make in a day, and I think that this paracord handle serves the purpose pretty well for that type of knife. All right, guys, came out to the new shop to do some testing on our angle grinder blade, get some safety gear on. Got this piece of pine. It's a piece of 1 by something, and we'll see if we can chop through it without this blade breaking into 3 pieces. Welcome to another edition of Will It Chop, where we chop stuff that you probably shouldn't. Golf ball. Golf ball? That's not a golf ball, it's a tennis ball. All right, so I think we need something a little bit harder to chop than a tennis ball. These should be a little tougher.
It's alive!
Just exploded.
It's like it has a mind of its own.
Well, it's late. I'm tired. My arm hurts. And there's trash everywhere now. So if you want to make one like this, follow the video, subscribe, like, see you later, bye. This thing is big, it's ugly, but it's something that can definitely be made inside of a day with proper preparation. So if you like this video, don't forget to like it, please subscribe, leave a comment down below, and let me know what you think. Love to hear from you. Again, thank you for watching, and we'll see you in the next video. I don't even like, I don't like this. I mean, it doesn't feel right. It really doesn't. That, I don't know if I can do this. I literally felt like I just cut my hand off.